Hello. Sorry I'm late. Um, yeah, I wanted to start this thing at 5:30ish, because that's like when I get off of work, but ran a little late today, um, with some stuff. But anyway, well, I'm trying to get the camera to focus right now. Today, I think the plan for this session is mostly to continue building this actual design that we came up with last time. Um, it's uh, it's an interesting design. I don't know how exactly I'll make it, but um, we're just gonna continue with uh, what we have. Last week we left off on creating. I think we created a template and then traced out onto cardstock, or not cardstock, cardboard. Um, you can actually see this is from a Cheerio, cereal box. So it's a little stiffer than regular paper and cardstock, but we're using this as a fuselage base. I think I cut out the template for the wing, which is here. This looks a little bit weird, but if you fold it in half, which I don't really want to do right now because it's a template, I want it to be as flat as possible. It is basically one side of this design, and it includes the integrated winglet right here. As you can see, there's a change in the taper of the wing here. So this is forward swept, so then this part out here is going to fold down like winglets. And I guess, yeah, that's kind of where we left off, was coming up with this design last week, and then, it's kind of just designing the thing on paper, having a concept down. And then this week we're just going to continue making these templates, and then hopefully some actual parts, to be able to make this thing. So I think what I'm going to do right now is just kind of look at it for a second, because it's been a week since I touched this project. Didn't end up getting a build session or design session last weekend, after Friday, because the weather outside was just so nice. So not that I went outside, I just enjoyed the nice weather and took a break from building. Let's see, how do we want to approach this? I think one of the main problems about this design was I wanted to find a better way to integrate the aft portion here. So this is a twin boom configuration, so that means there's like these two thin pieces going back. The way I've done it kind of in the past is to use straws that are like this. So this type of straw is really nice for relatively lightweight structures. You can see it does have some resistance, and for things like these surfaces here, which don't experience a ton of load, at least not at this scale, using straws are perfectly fine. I think I mentioned in my last stream that I didn't want to use these straws, mainly because it's hard to work with, and I stand by that statement. But I'm wondering now if there's a way to include these, because they are, instead of like cutting a piece of paper and modeling this section right here, which would take a lot of extra time, and this is a rapid prototype, we want to save time. If there's a way to combine using paper with you know, with this kind of a material to obtain some type of boom design. And so the idea that I have in mind was something where, if you look up, straight on onto the aircraft, you have your boom, which is going to have like a circular cross section. And I'm wondering if like you could reinforce it with a sheet of cardstock. This would be nice because if your plane is like at a high angle of attack, imagine it like it's like this and then the air is flowing past it. If it's kind of sharp like this, it allows that to happen better. I know this is like a nitpicky thing because you're not supposed to be designing for these like high alpha conditions, because if your plane flies fine, it won't be in such a high alpha position. But I just think it's nice to have like an aerodynamic leading edge if it does end up being high alpha. That's just like a random idea. I'm just trying to figure out a better way to integrate it. And again, the reason behind wanting to do this is, first of all, it's interesting. I think it's cool, but also I want to figure out a better way to build the aft end of the M1 variant of the YX10 Astra that I showed previously on streams. Let me try and pull it out real quick. So here's the prototype for the YX10 M1. It's a work in progress. And if you look at the past prototype, which I have here, it has vertical stabilizers that are mounted directly on the wing itself, which is, it resulted in some performance issues where there were, in flight, it would tailspin often. So in this redesign, I want to move the vertical stabilizers aft of the main wing. So by moving it here, we're essentially giving it fresh airflow at high angles of attack. And that's really nice for yaw stability and maintaining, I guess, just maintaining yaw stability. And so to do that on the new prototype here, I want to figure out a way to mount vertical stabilizers aft of your main fuselage and body. So that's kind of the reasoning behind that. Just put this aside. But yeah, this is a interesting design exploration. I don't want it to take too long, but also, I want it to be good quality results that we can use elsewhere. And that's kind of the whole point of these rapid prototypes, is to develop ways and techniques to build things, but in a more rapid manner, instead of a full-on, YX design. Because typically YX designs for me are, kind of like, this is everything you've got. You're putting all of it into a project. So let's see. So we have these two prototypes, or not prototypes, these two templates. I think, I said making more templates. I think the only other template that we might need for now is the template for the vertical stabilizer. That's going to be an interesting piece because this is in an A-tail configuration. So what you see on paper is actually just a flat projection of what's actually there. So if you look from the top, it's going to be something like this, where it's a V shape. So we're gonna define that shape, but that shape alone is not going to be sufficient to create this A tail. Since it's coming out of the page vertically, and so there's probably going to be some math involved with that, just to get the sizing right. It's not to really calculate exactly um, what we need, but just to get an idea of how large on a sheet of paper it needs to be. But anyways, I'm just like rambling to myself. I think I saw a comment earlier. Um, Out of curiosity, how many planes or including prototypes, have you made over the years? Yeah, that's a good question. I'd have to say I don't know. um, in the past, I've built, kind of lower quality airplanes very rapidly, and so I've kind of lost count to how many. But if you've ever seen one of those, I think it's like X6 or whatever, the paper boxes, um, that whole paper, like just like entire reams of paper. I filled two of these boxes full of prototypes. So, and I gave one away. I gave a box away to a family friend who, um, well, they had a little kid and he was super interested in, the wing deployment mechanism of the F-14 Tomcat that I made a while back. So I gave that entire box to him. But, like if I had to estimate, it'd probably be around 30, 40. That would be like on the high side. 40 would be on the high side. I don't know if it was that many, but I started this kind of interest since in 2010, I think. Yep, that was when I moved to a new school, and then I was in middle school, and I was just after school I was just tossing paper airplanes outside my apartment at the time, that our family had, and they were just simple dart airplanes, you know. Um, yeah, the camera's not really focusing. I don't know how to solve that problem. Tapping, but it's not recognizing. Anyway, and it just kind of started from there, just dart paper airplanes, and adding wing extensions to make them more interesting, I guess. Just building things from there. The first mechanism came about when I tried to replicate the F-14, which has swing wings, as you might know. And then that kind of just, I wouldn't say that one in particular started me down the path of mechanisms, but just an interest in general of how things work, like, gears and levers and stuff, just kind of pushed me in that direction. I was like, there's really no other way to innovate paper airplanes, at least. Unless you try and go into the details of mechanisms and whatnot. And, that is what I'm trying to do. I'm showing off this prototype a lot, but it really does represent, what I really want to dive deeper into, is that the whole concept of mechanisms in a paper airplane, it's like, it's totally over engineered, right? Obviously you don't need a mechanism to get a nice flying paper airplane, but there's something about just pushing against what the expectation is, and trying to do something that's not been done before, even on this scale, right? You've never heard of like paper airplanes with mechanisms, like what, right? It's always RC planes that get the most attention when it comes to like, oh, this guy designed this jet engine that he mounted on this RC airplane, and that's really cool. But at the moment I don't really have the equipment and capital to do that. So I'm doing what I can with the materials that I have right now, which is just you know, hobby level, like desktop level, building, you know, builds and stuff like that. And so that really limits me to just paper aircraft at the moment. But, I do eventually plan on having like a workshop, so that I can work on RC projects, which would be more amazing. I feel like, that's like the next leap, but that takes a lot of, um, you know, money and, you have to have the space, and you can't really do that in an apartment. So, um, but yeah, that's my like kind of future plans. But yeah, that's kind of on a large tangent there. I, yeah, I would say probably maybe 30 to 40 prototypes max that I've made over the years. Um, I'm just looking at some of the comments. What's up, bro? Beautiful build. Thanks, Rogers. Pep rockets. I know, right? Yeah. Well, anyways, I'm might have repeated myself, but I might be repeating myself. But I'm trying to continue the build today. Last time we came up with the concept here. We have a template that we traced out and folded in half to get symmetric, and we cut that out and use that to create this piece, which is going to be part of the center fuselage of the new design. As you can see, it's just a Cheerio box that's been cut up. We have the wing template here, which is double-sided. So if you fold this in half, it actually gives you this shape that we intended here. And it has the integrated winglet, which is going to be downwards folding, but still need to actually manufacture the wings. And I was thinking, before I do that, to actually make the template for the vertical stabilizer, which is going to be interesting because it's an A-tail. And so, how do you can plan overhead and draw like a shape to really model the A-tail, like a V shape, rough shape like that, right? But then it's like, there's this height involved too, so it comes out of the page. So how big is it really, right? So I'm trying to figure that out. And I don't know exactly where to start. I feel like for the sake of prototyping, I might have to eventually fold this just to see how the wing fits on here, because it's kind of hard to see when you have like another section here. So I might just do that. Let me just fold this real quick. All right, so you have, straight edge like this. And you have your other ruler. You line it up and then kind of just pinch it. Kind of fold it like that. And if it's not long enough, you just kind of move it up and down. All right, so we got a crease, pretty accurate fold. All right. So now we're just gonna increase that fold and then reverse it to kind of get rid of the directionality in the fold. So it wants to go one way. Yeah, so this is kind of what the wing will look like. Of course, the winglets will be curved in the actual thing, but we need to have an idea of how it's going to look attached to the actual thing. Oh, that's right, I chopped this triangular bit off last week to make it easier to manufacture this wing. But it goes from, currently it's, I think it's like 4 inches from the tip, from the nose, and then 4 inches from the tail, so this is exactly 1/2. We set the length of the fuselage to be 8 inches, and that's from a hand wavy 2/3 ratio that we took last time based on the 11-inch paper. And so, okay, so this looks like about where I want to place it. Right, so this is going to be interesting because I am using a ruler that has centimeters. And this one also has centimeters. Dang it. Where's my other ruler? No, I used to be one of those people that was like, I will never use inches in my life because, you know, in high school and middle school, you're taught to use SI and like units, the international unit, right? System, anyway. But in the actual industry that I am working in, we use inches all the time. And inches are actually great for making things because you could divide it into halves, quarters, you know. Let's see what the wingspan is on this thing. From the center line, it appears to be about 5 and 5 5/8. That's to the winglet. We don't really care about the winglet. Let's see, to the root of the winglet. That's about 4.5-ish. So we take that to be 4.5. Okay, so that's more like 4 3/4. I am bad at measuring. 4 3/4. Oh god, where did I leave my pencil? Ah, it's right there. Got it. So 4.75. 4 3/4, which is 16/19/4. Okay, so usually I like to use nice ratios when I size things. And that just makes it look a little bit more, I guess, proportional. You know, everything is in proportion to other things. And so, you know, usually I go with thirds are nice, quarters are nice. Sometimes 1/5, but not really. I don't really use that. Definitely 1/2s, you know, like 1/2. Because definitely, like, this is how I kind of sized where the leading edge of the root would be. Is 1/2 here. And so, okay, so we have kind of a thing here. So let me just move this paper over a little bit. What I'm going to try and do is kind of sketch out where the boom is going to be. I mean, honestly, it doesn't matter too much, because we could even place it up here, because it starts at 1/2. Yeah, so, you know, kind of just go with, you know, what you feel is right for these types of things. And, you know, this is something that I can't really teach. This is where your design sensibilities come into play. I feel like about here would be nice. So this is like 1/3 of the span. So it'd be no, it would not be 2/3 because you're doubling it. So it'd be 1/3 of the entire wingspan, which would look all right, you know. That's a nice ratio. So if it's 4 3/4, 4.75 on each side, that's not to the wing tip, unfortunately. So actually we're taking 1/3 of the, you know, wing here. So maybe we should include the winglets, because they do come out a little bit even if they fold down. Try and get that measurement. So the wing, what's the size gonna be? Oh, right, it was 5 5/5, which is 45 over 8. So if we double that, that's 90 over 8. So that's the entire wingspan. And if we divide by 3, that's going to be 30 over 8. Which is less than 4. It's going to be 3, 24, 6, right? 6 left over. 6 over 8, which is 3 3/4. So if we want this to be 3 3/4, okay, that's interesting. What should the kind of the root here be, right? So I'm gonna sit down now, just to get a better. Actually, we can move this closer. See if that helps. Yeah. All right, that's a little better. All right, so. All right, so I want to determine the size of this root. From this sketch, it looks like it's about the same, maybe a little less than. Okay, so it's definitely less than the root chord here. I'd say maybe like it's a 80% of this, and you know, it's not this entire thing, it's where the root would interact with the fuselage. Maybe not 80%, maybe like 90%. But let's see. Let's look at the measurement here, right? So if we look at the length of this, it's about 2 inches. So we can take like a, I don't know if a half is appropriate. Half an inch off, so that's still a lot actually. But does it taper? It does not taper. So maybe we should just go with half of this. And again, what's interesting about this is that whatever length you have here, it's gonna appear to be more slender in the middle because it's it's a parallelogram. So you're just defining one side of a parallelogram. So it's not like this where you have x and then it goes like that. It's like x here and then it goes diagonally. So it'll look more slender, but it's actually the same, or you can fix that to draw it to be the same. So I'm sizing this based on aesthetics, not based on physics. I am just putting that out there right now. There are proper ways to do this, and I am not doing it. So, I mean, it is, a prototype after all, and I am not a professional airplane designer. I don't work at Boeing. Let's see. So we know it's going to be this wide. How much do we need here, right? That's a good question. I think maybe like 1.5 or 1.25, right in between 1.5 and 1. It's like that would be about this size, right? Which seems appropriate. If it slants forward, it'll be a little bit more slender. Maybe 1.5. I'm not sure. Goes forward like that. I'm just trying to envision what it's going to be like. So if we put this wing here, we would lay up. Just place a ruler over that to just kind of clamp it down. How far back is another good question. Like, how long is this boom, right? But just eyeball it for now. We know it's going to be this much coming out. So actually, we can mark where it's going to come out on the actual wing. So we divide that by 2. Get 1.5. because that's 3, and then 3 over 8. Dang it. Alright, let's see. 12 plus 3, that's 15. Yeah, 15 over 4. And then 15 over 8, which is going to be about 2, a little less than 2. 1/8 less than 2. That's great. Alright, so 2, and then you take an 1/8 off. It's going to be about here. Let's mark it on the actual wing itself. So that's a half, that's a fourth, that's an 1/8. I think that is right about where I want it. Yep. Alright, so this is where we're gonna mount the wing, or mount the boom. You know, this long thing coming back here. I could probably have done that better. Honestly. There we go. Much better. And we want it to come in here, right? And this is where, like, you know, you kind of have to have a sense of design, which I'm not saying I have a great sense of design, but I like things to, like, be parallel, is what I'm trying to say. So this line right here, this leading edge of the control surface, right? So it's gonna, okay, so obviously this is too slender, so it needs to be thicker. Alright, so I'm planning for it to be entirely parallel like that. I mean, it's like not parallel lines, but, you know, like parallel curves. So they match each other. I can't talk. It's been a long day. But this is the surface that I'm aiming for. And basically I want this to be parallel with the leading edge here, was what I was trying to say beforehand. That's gonna be kind of hard to eyeball. Take a shot. I still remember some guy commented last week, take a shot every time he says, I'm just gonna eyeball it. But, you know. Yeah, it's kind of like something like that. Maybe it's alright to have it a little bit more slender. Maybe it's okay to match this leading edge with this trailing edge, you know, because that creates more harmony here. Which is an interesting concept. Right, something like that. And then, you know, it goes onto this side. And then, you know, we know that this is the kind of span. So the span is 3/3/4. So half span is going to be, we had that 15 over 8. Just going to move this up a little bit. And how high do we want it to be, right? So from this sketch, it looks like it's about the height of this fuselage, right? So if you have a sense of proportion when you draw this out, it's really nice, because when you look at it, you're like, oh, cool, that's 1/2 of the fuselage. So whatever this is right here, this is, you know, imagine this being revolved in space, or something similar to that is what our fuselage is. This thing is 1 1/4, almost exactly, at the halfway point. So 1 1/4. So really, if we're looking at it head on, it's, you have your triangle, right? So this is one side of the boom, and you have your A tail, something like that. So we know that this is going to be 15 over 8. and then this, which is a 90-degree angle, is going to be, what do we just measure? 1.25, right? So that's like 10/8. And would you look at that? 10/8, 15/8. That's 2 to 3. 10 to 15, 2 to 3, right? That's a nice ratio, again. But, you know, based on eyeballing and whatnot, that's about a third, yeah. Draw like a 45-degree. Okay, maybe this is not totally accurate, but all right, so we have our height, we have our span. How much do we want to sweep this, right? I mean, like, the alternative way to do this, which is easier but more resource intensive, is to actually prototype it. Just like cut out a larger piece here and then cut it down. But, you know, I want to have less to do, more thinking, less doing, I guess. Sorry if I'm low energy. It's end of the week. It's been busy. All right, so it's gonna look something like that. Yep. Yeah. If you guys are watching, this is more intended to be like an open studio session. You're not supposed to like just watch the entire thing. I feel like that would be very boring. I would encourage you to work on your own projects too at the same time. You know, just have something in the background. And if you have questions, you could send them through the chat area. Let's see. So this is interesting. I think I don't want to taper, right? We said it wanted it to be parallel curves all the way. So that looks about right. So it's actually going to be a little longer than this because it has some height involved too. So I'm not sure if I want to do the full calculations for this. I'm thinking too much like a engineer, less of an artist recently. Trying to figure out the best way to proceed with this. Well, let's see. We're definitely not going to make the full thing yet because we don't know the correct shape, and spending that much time to get like a double layered version of this is kind of not the right way forward because you're wasting time. So if we just cut out a simple layout and then try and fold it, model it to our wing points here, I guess, for lack of a better term, we can see if that works. Okay, so what's that gonna be like? I can start out with this shape right here. I don't need the full thing either. We only need half of it. I mean, this is going to be undersized, obviously, just because it's not the full geometry. It's a projection. So if you take the projection and then try to make it into the actual thing, it's going to be a little short. Right? So as you can see on the layout, it looks about the right size. But if you make it, into a 3D shape, you're missing like a chunk, right? Sorry about that. It's off camera for a second. So if you fold it down, yes, it looks about right. It's a little bit off actually, but if you bring it out into the third dimension, height, and then look at it, there's a gap, right? So you need to account for that in your design. So let's say like increase it by maybe like half an inch. That would do the trick. So let's just take this shape right here. Oops. So we have a random sheet here. Just kind of trace this out roughly. Let's try to make that parallel with the trailing edge there. And then whatever length this is, looks like it's about 7-ish centimeters. See, I'm mixing my units again. Dang it. Yeah, 2.5. All right, so let's make it 3.5, right? So there to there. And just cut out a rectangle because we're just prototyping right now. Alright, so this is kind of what we have. This is half of what we want. Right, so this is going to be parallel to this. And so, let's move this a little bit. Right, let's move this camera down a little bit. Alright, there we go. So if we make it parallel like that, and then fold it up, because we want this to be like a straight line, right? That's interesting. That's gonna be interesting. I think I might have to join this separately, so have each side do its own thing, and then in the middle cut down the overlap and then join them together. That would not be like an ideal, like, smooth structure anymore. Let me just tinker with this. So maybe we need to go a little bit more. Something like that. Well, this process is really rough. It's not supposed to be clean. Final product is hopefully going to be pretty clean. This is the nice part about CAD, is that you design it all in the computer and model, and then you can just print it out using a 3D printer or whatever, you know. But most people don't have 3D printers, so but even like, you know, regular printers, you can export the 3D geometry into kind of a, what's that gonna do? Yeah, you kind of like lay it flat. I know that's like how Master Paper Aircraft does his designs. Highly recommend it. $10 each, I think. But he does these really nice 3D models that you can build out of paper, and he makes it using CAD. So this is just a rough prototype. Oh, it's right here. All right, so this is kind of like another test. Yeah, that looks a little bit more reasonable. So you lay this flat, it's a lot more, you know, gap here, but when you raise it up to a proper level, again, this is not perfect, but something like that, which is nice. If you look at this, you know, imagine this has an A-shaped tail. This curve is really nice. If you look at that, it's like a nice way to end it here. Yeah, I think I might keep this. This is a nice general shape, and I just need to duplicate it on the other side, and then make it at least duplicate the leading edge here. And you know, like thinking back, I don't think I actually did a full double layered part here on the last I think it was like prototype 001. It was a folded leading edge, dual layered leading edge, but then a single layered just rest of the surface. And that makes it really durable and light. So the leading edge is really kind of reinforced and smooth. It has like an airfoil shape when you fold a piece of paper over, right? But then it's like, you know, you don't really need it to be fully 2 layers, especially because it's a rapid prototype and it's not supposed to last that long anyway. In a proper build like for the Astra, I would definitely use a double layered approach, but here I think I'll just double layer the leading edge, maybe up to the halfway point or the third, you know, a third of the chord here. But yeah, that takes me to my next point, which is the chord. Does it look about right? Right? So if we line this up, it's like, all right, it's a little thin, which is nice, I guess. But it looks okay. I'm wondering what this measurement is actually. I think it might be 1.5. Nope, it's 1 1/8. Is that what we want? 9/8? It's about 10/8. It's a little bit less. Okay, we can do 10/8. Make it a quarter, so start from here instead of here. Make it a little bit larger and then make the full layout. I'm gonna do that next. Just get the sizing right. what is this angle? Anyway, we could do all the trig in the world, but it's not going to build us a plane. So let's see. Here it's like apologies. Let me just shift this camera up a little bit. So we extend it out here. And, oh my goodness, all right. So it didn't actually draw the line for some reason. I think it might be because my pencil was actually on the part itself, template itself. Okay, anyway, problem solved. Alright, so this looks alright. Just clean up this area a little bit. Alright, cool. Now I just want to link that over. And then so in prior template here, it's like a curve like that. You know, that's an interesting idea. What if we just made it 45 degrees? That wouldn't match the wing, but that's an interesting idea. So it actually thickens here in the middle, but it appears thin. Not sure. Well, let's see, hopefully this. So make it more round. Sharper corner here. Oh. That looks a little better. Actually remember because well actually we could try and get a 45-degree line just from kind of the mat underneath. Right? Kind of like that. And then, oh, that's a coincidence. Look at that. This line matches this pretty close. You can use that to trace out a rough shape. Looks like this is more outwards leaning. Oops. I just drew on the mat. Anyway. Alright, so this, I'm gonna start cutting this. So this is the side that we want. And wow, that is actually quite a bit off. Anyway. Fold it so that we can strain one edge to match. This is still a little bit off. Damn. Alright, well, I'm gonna trim this outer aft edge here off. Look at that. Oh, that's a nice shape. Yeah, something like that. And then just take this. And try to do a layup. So it's a little bit large. Let's always be a little bit large rather than a little bit too small. Because you can always trim down material. Yeah, I should trim this side down so that does. So fold this and trim the excess. Okay, so we actually want to keep this side, right? Yeah. I think that looks about right. I'm gonna wonder like how to integrate this with the boom itself, right? I'll like slice the tube, or slice the straw down the middle, and then wrap it around, and then use cardstock to really reinforce that. That's an interesting idea. Now, if what if we just sliced it on one side, not the whole way through, right? That way, when you place it in, it doesn't come out the other side, but it does wrap around really nicely. And then you can fold it flat. So that's like a nice transition from a round cross section to a flat cross section. Yeah. I might actually just do that. So that's gonna be this eventually going to this, right? And then, the top part is cut so the paper can come in, but then you have another layer protecting everything. Yeah, I think that might work. That might actually work. Alright, so I'm gonna lift this up a little bit. Let's see, this geometry is a little bit unconstrained right now. Not this one, this one. It is, not that ruler again, the inches ruler. Yes, it's a little bit finicky. Definitely want to keep the larger side of this. So I think I'm gonna cut this apart and keep the larger side. So I'm gonna label which side to keep. Oh, keep this side. And we're just gonna trim that apart. Yep. So keep this side. We are going to do another one. So we keep it here. Let's just do some trimming here. Alright, so trace this shape down. Don't know if you guys can see that. Shift this down a little bit. There we go. And then you flip it over and draw it on the other side. Right here, I'm just marking out where the kind of the control surface is going to be. This is kind of what we planned for originally in the sketch. So I'm just trying to emulate that geometry here. And we want to duplicate this leading edge. Here we are just making the leading edge double layer, so not a full double layered surface, but just the leading edge. So if you fold this over, it's going to give you a shape like that, right? And then hopefully that reinforces the leading edge of this A-tail. So let's just cut out this side first, or something like that. folds over onto itself. The symmetry to really constrain the other side, the geometry of the other side. Just trace out that edge where the leading edge fold over is going to be. Let's see, we'll match that shape pretty well already here. Just need to trace this little cutout here. Okay. Let's actually see if this works. Where we fold this part here back. That is decent. Not perfect, but pretty close. You see this? This is the leading edge, so on the final thing it's going to be folded in probably to make it look a little nicer. But it's going to be double layered there. And this is going to fold over like that. Good. Right. I'm gonna cut this out. Might be hard to build, I will admit. Just the A-tail in general is very finicky, but we'll try our best. Let's see how this goes. Excuse me. Measurements line up, which is nice. Although I don't know if I want to do that. So as you can see right now, where it mounts and where it folds does not quite make sense. So I think in reality it would be more like this. We're just kind of shaping it by hand. And just like wrapped around. Some kind of round shape here. That looks a little better. Yeah, this is kind of hard to make right. Looks like we need to step this up a little bit. So we need to cut an angle into this in order to get it to be right. That's just going by feel. Again, this is not a scientific process. That's kind of okay. Yeah. That is reasonable. So I think we have the mold for our A-tail. It took a couple of iterations to get it right. Let's just do a kind of a layout here of a sizing fit test. So we'll constrain that to be right there. Pin it down. This looks awesome. It looks alright. Not too shabby. I think it might be a little too steep, but honestly, because it's a rapid prototype, I'm not too keen on iterating this too much more. Right now it does look like the trailing edges are parallel, which is nice. I just need to figure out a way to build this. And to do that, we would need the actual pieces to this thing. Let's see. It is 7:25 right now. I think I might end this build a little bit earlier today, just because I'm a little low on energy. Just move this out of the way. But yeah, I think we have the main templates done. It's just now we need to really just make the actual parts that are going to be a part of the build. Sorry, I'm just trimming some of the geometry down. Yeah, that is interesting. Alright, so one thing about this is that the middle section here at the top of the A-tail is not double layered, unfortunately. I don't know what this is gonna mean for the performance, but it's just gonna be a little bit weaker in the middle here. Yeah, that's gonna be interesting. But this, this double layer is interesting too because it creates an airfoil shape. We can even, crush one of these straws and then place it in the middle to give it even a little more thickness. Now it's kind of like a lip, but I'm not sure if I want to do that. But definitely do have the templates done, so got something accomplished today, which is nice. Yeah, this bottom bit, again, how it's going to be attached, I think I might include a slight curve up here. So this is just going to be like an eyeball feature. Okay, so this is going to try and match that curvature. Yeah, well, I don't know if it matches exactly, but it gets the concept across. Maybe a little bit steeper like that. So now we're just gonna trim that real easy. So when you have the actual tail, it's gonna have a nice, smooth, organic shape. Yeah, this bit right here is a little interesting. Don't know if well, yeah, it's gonna be all right. It's gonna be all right. Anyway, yeah, all right. Let's double check if this matches. If it doesn't, I'll have to trim it down where it doesn't match. Alright, cool. This is the template. Nice. So we have the template for all the major parts here. We use this template to cut out the fuselage. We use this. Oh, we did not use this yet, but this is the template for the wing. This is the template for the vertical stabilizers. Now I am going to clean this area so that I have a little bit more space to work with. Again, it took a couple tries to get the shape down. That's where design comes into play, I mean, you could just eyeball it, but then it's like eyeballing without much thought. It's not gonna get you anywhere. I knew a guy like that in college. He just built RC planes based on feel, and I'm not gonna lie, some of the designs looked kind of unbalanced, but did they work? Yes, but it's like, could it have been better? Yes, if you just put some thought into it. But anyway, I have these scraps to one side. Move this drawing down a little bit. Move this camera up a little bit. Let's see if it's aligned properly. Yeah, today is really of a work session. I'm not really talking that much because I think if I talk too much, then it's like can't really make things. So we have the templates for the wing and the tail. So we should be all set. Gonna get some cardstock to start to actually manufacture the parts. All right, so this is the drawing. Lift it up a little higher. All right, there we go. Come on, camera, focus. Anyway, put that drawing in the corner there. We have our 2 templates that we need to make parts for. Luckily, we only need 1 of these, but for the wing, we do need 2 of those, so. I'm just grabbing a piece of cardstock right now. Off camera, that is. Hopefully this will be enough. Just 1 sheet for now. Alright, so we have our cardstock. This is 165 gram per square meter material. That's kind of the density. That's a little damage here, but it's a stiff kind of paper, if you can tell from this live stream, as opposed to regular printer paper, which is really pliable. This is a little bit stiffer. The properties are especially amplified when you fold it in half. It becomes a lot stiffer than if you folded regular paper, printer paper, in half like this. So it's definitely a better material. I would say, like in terms of scale, it's probably more similar to steel, like rolled steel sheets in real life, than aluminum, right? So regular printer paper, probably aluminum. Cardstock material right here is probably more akin to stainless steel, or sheets of steel. So let's try and make the actual parts here. You notice, like, I mentioned this in the last stream, but you want to try and save as much usable space as possible, right? And that's not only to be eco-friendly, it also saves you time in the manufacturing process. Because what's happening is, like, I'm saving this entire edge here. I don't have to cut that because I'm using a straight edge of the stock material itself. I'm just tracing out the shape. that's the general rough shape. And okay, so we need 2 of those. And so now we can align this edge. Maybe not. Maybe this is actually better if we do that. Because then after we do that, we have 2 wings here. And I'll just move this up a little bit. I can fit this around this and then save some space here. Yeah. Or we could use that side, which would save space, I guess. Yep, and then we would have a massive section in the middle. We could do that. Just clean up this template a little bit. You can see there are little fringes on the edge there. I'll just trim that a little bit. All right. Let's make sure it still matches the previous one. Just move that down a little bit. Around like that. Yeah, that'll produce a lot of usable space. Move this down slightly more. Nope. No, I'm just kidding. Move it back up. Alright. So I'm gonna trace this out. And then you don't even need that line because you're sharing a common line. Looks about right. The nice thing about not having anybody watch the stream right now, not that I'm complaining, it's actually great because I don't feel as much pressure anymore. I'm having to present and be fun and interactive. That's just not me as a person. Yep, I just traced out the A-tail layup onto the actual cardstock. Yeah, this is turning out all right. I might want to do this bit here. It's like this bit, not sure, because right now it doesn't fold perfectly level with the center line. It's like outwards canting a little bit. So to make it inwards canting, we need to make it a little bit sharper. So it's always better to go a little more, because then you can trim off later. I think that's the general gist of this part here. Just cut down the middle there. You can spend time to measure and get things right, but sometimes just seeing if it's good enough is probably good enough, you know. There we go. So the way we put it here minimizes the amount of extra edges that we have to cut. And so this edge is already pre-cut into a straight perfect line. Just need to trim that, this, and then this edge here is shared by these two regions, so it'll save a lot of time. Downside is you gotta cut it really well, otherwise you mess up two parts, right? So you gotta keep that in mind. Cut this really well, which I have a tool for, fortunately. And then this part here, and then this rest of this part here. This edge isn't perfectly aligned, but I think it might be close enough. We could just do some trimming, so that saves time too. So a lot of this is just trying to be smart with your resources, trying to get parts to be close enough to be accurate to each other, trying to save material, trying to save your own time. I'm spending more time here actually building this because I'm doing it live, but you know, in your own time, you just do your own thing. And yeah, I don't know where I was going with that train of thought, but we're starting to cut this. I think I'm gonna do a rough cut all the way around here, and that way it's just easier to handle. I don't have to like hold on to this the rest of the paper here. That's just to, you know, make it easier on me. don't have to worry about those corners yet. Just try and get the rough shape out. Right. Though for these corners, you can spend the time now because they will have to be precise eventually. Yeah, I just trimmed that. And then I'm going to start out here because that's in the middle already. It's a little hard to cut, but actually we don't even need to cut really close to that yet. Just come out here. Trim to there. It's not likely that we'll use that triangular section, so it's okay to make a rough cut like that. Yeah. This is where it gets kind of hard because the lighting is creating shadows that are interacting with the lines that I'm trying to cut on. Trim that little bit here. Right. Trim that feature there. I can trim this. And trim this round edge here. This is a very important feature. So I'll try and get that to be really nice. Yeah. Such a nice round edge. It feels a little rough. You can easily fix that up with a couple of corrections. That's better. It's never going to be perfect unless you use like a CNC cutter or machine, but I don't have that, so I'm not going to really use that. I am going to get a cutting board real quick. Got 9 minutes left in this stream. Hopefully it can end by 8 so I can have dinner and relax a little bit. It is the end of the week after all. So with this machine right here, I don't know if you can call it a machine, it is a tool. We are going to attempt to cut the wings apart, the two layups. So if we zoom in closer, get a better look, and also I can look here. And then I think I have it down. And we made a cut. And would you look at that? That is so nice. So I highly recommend getting a cutter if you're going to be doing a lot of these straight line cuts. But yeah, that was nice. Fiskars, if you're out there, I would love to be sponsored by you guys. Anyway, that was a cutting board from Fiskars. So, all right, I'm moving this arm up a little bit. Camera up. Alright, so now we are going to just trim the rest of this down. Right. Alright, that is a nice cut. So we have one of our actual parts for the wings done. Yeah, that's a pretty straight line. Yep. Just trimming my way through this. I think we're just gonna finish today with making the parts. Today was mostly, well, last time was conceptual design, getting it down on paper, and then having a head start on creating the actual parts themselves. Today we made some templates, or finished making all the templates from last time, and then started making the actual parts, which for this design is fairly straightforward. We're starting with the two wing sections, each wing, and then this unified A-shaped tail, which we are about to cut out right here, trim to shape. But then after these parts are made, we can then, next time is going to be interesting. We're going to start to, incorporate the airfoil here, try to build this section here. That's where the stuff gets interesting. Yeah. So it takes some time, but we are slowly but surely getting there. It's supposed to be a rapid prototype, but in the olden days, this process used to be a lot quicker, but the results, didn't really last that long. If that makes any sense. The planes were poorly made, so they didn't really last too long. My philosophy has shifted over the years to spend a little bit more time, as in a couple hours for each one, and then have something that's durable enough to last multiple months even, but that's just a change in philosophy. If you want to go fast, you definitely can. You can cut corners, you can, not literally, but because I'm doing that right now, but you cut corners figuratively and save a ton of time and have a plane ready to go. But that's not really what I'm about anymore. Instead of making a lot of mediocre planes, I would rather spend time to make a decently crafted aircraft. We're just trimming out the inner curve section here that we marked out earlier. This section is a little hard to cut. So you know what? Actually, I'm just going to use an X-Acto knife to cut out this section here. And that's the nice part about having one of these cutting mats, is that you don't have to worry about damaging the surface underneath. Actually, you could use an X-Acto knife to cut templates too. It's easier than using scissors. You can use a straight edge too to cut a very nice line. But all right, so the exacto knife didn't quite cut through. That's why I'm supporting it with a little bit of a scissor action here. So yeah, we have our part. Nice. All right, so you know what? I think that's gonna conclude today's session. A little under 2 hours, but we did a lot. We were able to make this, define it from a concept sketch, which took a lot of time. We were able to make this shape, determine it, make sure it's all set, and then use these two templates to create these three parts, you know, the two wings and the A-tail in the back. So we have these parts made. Now all we have to do next week on Friday is to actually start building out this fuselage shape. And that's where I think most of the fun is going to be. And so yeah, that's gonna be pretty much it for this live stream. If you're watching this at a later date, if you have any questions, feel free to leave them in the comments section. If you're still watching, I know there's one person watching. Have a nice day, and thanks for watching the stream. As boring as it may be, just trying to do this for myself to, you know, get something done for this hobby. So, yep, that's it for today. Thanks for watching. Thanks for tuning in.